Euler's planar graph formula. Says that for any connected planar graph with V vertices, E edges, and F faces, the following formula holds. So if I take the number of vertices and subtract the number of edges and then add the number of faces, it's always equal to 2. And so we need to talk, so it is clear from what we looked at already what the vertices are and what the edges are, but we haven't really talked about what are faces. So let's do an example. Let's verify that Euler's planar graph formula holds for K4. So remember what K4 is. It's the complete graph on 4 vertices. So it's 4 vertices and each vertex connects to all the other ones. And so the standard representation for this usually is the square with a X through the middle. But we want to draw this in a planar way so we can see how the planar graph formula works. So here's another representation. I won't use the same one I used last time to show as planar. So I'm going to arrange A, B, and C like this, and I'm going to put D in the middle. And so notice I can connect A to C and B, and then also to D, and then the same thing with C and B. Okay, so this is another representation of K4, right? And so let's count things here. So vertices, how many vertices do I have? So 4, that's what the 4 in K4 is telling us. How many edges do I have? So 1, 2, 3, 4, 5, 6. So I'm counting 6 edges. And then faces. So faces are a little weird in that there's always an outside face. So let's see how that goes. So here's one face. There's 1, 2, 3 faces there. And then plus 1. And the last one, we think of this as the outside, is this one, right? So this would be face 1, face 2, face 3, and then face 4 is somewhere out there, right? It's the outside of the boundary. And so this really is 4. And so if we verify the formula works, we have 4, right, so it's V minus E plus F. So we have 4 minus 6 plus 4. What is this equal to? This is negative 2 plus 4, so it's 2. So it works. Let's do the same thing for K25. Let's draw the standard representation and then we'll make it planar. Or draw a planar representation. It always is planar. Okay, so here's 5 vertices. Gotta connect these two things to all of them. In any complete bipartite graph with one of the numbers 2, you can always do the trick we did before, which is put one of the 2 on either side of the column of B vertices and just put those down the middle and then connect. Again, this to all the other 5 and this to the other 5. And feel free to label these and stuff if that makes this easier. Okay, but now we have, a planar representation of K25 and we can count vertices and edges and faces. So vertices is going to be 7, right? We have 2 in one column, 5 in the other. Edges, we said, should be 2 times 5 from the last homework, so that's 10. And then faces, what faces do we have? So here's face 1, here's face 2, here's face 3, and face 4. And then the outside face, the face outside of all the boundary, will be 5. And so this should be 5. And so the formula is V minus E plus F, and we should get 2 always. So 7 minus 10 plus 5 equals, so this is negative 3 plus 5, which is 2.